Hello everyone, this is Charan and my roll number is 19EC01030. So the main aim of my experiment today is analyzing train pan speech sounds and calculating and forming confusion matrices for the data that I have calculated. So I have divided my experiment into two parts. In the first part, what I will be doing is I will be taking the first 30 minutes of my sounds and I will be dividing them into 1 second samples, and I will be calculating statistical parameters for those data like variance, skewness and kurtosis, and I'll be storing them into matrices, and I'll be calculating threshold values for those data like using maximum and minimum or percentile method. In the second part, what I'll be doing is for the next 30-minute data I'll be dividing them into 1 second samples, and I will be calculating the same data as calculated in the first part. But what I will be doing is I'll be checking how many samples are present in the threshold range that I have calculated in the first part. With those range, with those accuracy values, I'll be forming confusion matrices. So moving to the code. So coming to the code view, I have performed my first part in a MATLAB file, and I will be loading these variables in the GUI such that the load on my computer decreases and the output comes fast. So what I have done in my first part is in the code view, I have audited my 1 hour of trying sound, and by using a for loop, I am dividing the first 30 minutes of my sound into 1 second samples. So I'll be getting 1800 samples. By using the next second for loop, I'll be calculating the statistical data parameters, that is variance, skewness, and kurtosis, and I'll be storing them in matrices. The same I have performed for fan and for speech. So I have written here some variables like train kurtosis max, train kurtosis min, fan kurtosis max, fan kurtosis min. So I'm assigning the maximum minimum values to these variables, and I'll be forming threshold ranges. I'll be using this data, these variables, by using a load command in GA such that the load on my computer decreases and the output comes fast. So coming to the GA part, which is second part, I have done it in App Designer. So what I have done is in the design mode, I have placed my radio buttons here in order to shift between different parameters, and I have placed a load matrix button in order to plot the data that I have collected, and I have placed 3 axes in order to plot the histograms of the different sounds, and I have placed a table in order to get the 3 by 3 matrix, that is confusion matrix. So coming to the code view of my GA, what I have done is I have splitted my second 30 minute into 1 second samples. I'll bring 1800 samples, and I have calculated statistical data, that is variance, skewness, and kurtosis for those samples. Same what we have done in the first part. I have done the same thing for train, pan, and speech. So after calculating the statistical data, statistical parameters, so what we are doing is we are just checking whether we are, suppose let's say kurtosis, we are checking the every kurtosis value is whether it is present in the threshold range what we have calculated in the first part by using the if and statements running in a for loop that is running from 1 to 1800, as we have 1800 samples. So here's the code. We are using if and statements and checking whether it is present in the threshold range of what we have calculated. If it is present, we are incrementing it by 1. If it is not, we are just leaving it. By this, we will be calculating accuracy values. So we will be getting 9 accuracy values for kurtosis, and using these 9 accuracy values, we are forming a 3 by 3 confusion matrix. So the same thing I have done for variance, and the same thing I have done for skewness, and I have used some inbuilt commands in order to plot the output, plot the graphs and get the matrices in the table. So let's run the code and see the output. So here comes the code. Let's load the matrix. Let's select skewness and load the matrix. As it is a bit lengthy code, it might take some 20 to 30 seconds. Let's wait. So here comes the output. Here's the histogram graph of train, histogram graph of fan, histogram of speech, skewness histograms, and here comes the matrices, confusion matrices, and here's the data for it. So let's skip to variance and load the matrix. It might take some time to change. Let's wait. So here comes the output. Here comes the histogram of train, pan, speech, variance histograms, and here's the output, that is confusion matrices of variance. Now let's skip to kurtosis and load the matrix. It may take some time. Let's wait. So here comes output. Here's the histogram graphs of the sounds, and here's the confusion matrices for confusion matrix for kurtosis. So by this, what we are doing is we are analyzing the second part of sound, and we are calculating the confusion matrices for the second part. So this concludes the experiment. Hope you got it.